Okay. So my name is Will. I'm HarmJ0y. Is this? Okay.
Yeah, you're good.
How many people have actually heard of the Veil framework? Anybody? Okay. Okay. How many people want to punch us in the face for doing fully functioning cyber weapons? Okay.
Yeah.
Like, at least like 2 people, so you can talk
There
to
we
us
go.
after and yell at us. So this is actually a modification of a talk we gave at ShmooCon, which is Evasion with the Veil framework. Since then, we've actually released an additional tool, Veil PowerView, that we're going to talk about in this presentation. So most of the content's the same, but some of the stuff at the end is modified just a little bit. So I'm Will Schrader, HarmJ0y. I'm a former National Research Lab keyboard monkey. About a year and a half ago, I started kind of getting into trying to research AV evasion techniques and everything. A few months later, teamed up with this guy, Truncer, kind of smashed the code bases we had together. Veil was born. I think the anniversary is actually in about
10 days?
10 days or something like
that.
that. So we've been going for a while. It's still pretty effective. We've still been releasing new stuff. We really like it. Since then, I've also branched into Cortana attack scripting, which I gave a presentation at B-Sides Austin about, and what else? PowerShell stuff. So I've really gotten into kind of PowerShell for post-exploitation.
I'm Truncer. I'm the other main developer right now for Veil Evasion project. I'm a former sysadmin turned pen tester, and this has really been actually my first major development project of any kind. So it's been a pretty big learning curve and experience, but it's been a lot of fun. Like you said, we're pen testers for Varus Group. We go on assessments daily or fairly often, and then we just love trying to research new offensive technologies when we can at night, and this is the result of some of our research.
Yep, and we're hiring, so if you want to come talk to us after, shameless
Yeah.
plug.
So let's talk about some of the things that we're going to go over today. We initially had this problem of AV evasion, or we identified that there was a need for AV evasion. We constantly hit this problem on our assessments, and we don't want to have to spend time to do or develop all sorts of different AV evasion techniques every single time, so we wanted a single tool that could do it. We'll go over our public reaction when we initially released Veil, and then we'll talk about the framework itself. There's 3 main components to it right now. We have our AV evasion component, which is obviously Veil Evasion. We have our payload delivery tool, which is Veil Catapult, and then our situational awareness, Veil PowerView. And we'll have multiple demos throughout.
So yeah, cross your fingers. We have hopefully 3 demos. We'll see if they actually all work.
Yeah. So this is our initial problem, virus total. What you're seeing here is a stock Meterpreter executable developed straight from MSF Venom, and it's being caught by 35 out of 48 different antivirus solutions that are currently available out there. The problem that we have is that AV obviously started catching more and more of our payloads that pen testers use, but and it caused a lot of problems with us trying to have to therefore spend extra time on an assessment to figure out how to bypass whatever AV solutions we were going against. We didn't want to have to spend that time and waste it doing that, so we wanted to figure out, is there something that we can do that we can actually use our time on an assessment assessing whatever, or the network or the system that we're going against versus this extra overhead time on developing an AV evading payload. So we had a couple different attributes that we wanted our initial solution to have. We wanted to be able to get or bypass AV as easily as different malware authors are able to do with their malware. That's a solved problem. Like, they don't have this issue because they're constantly developing new techniques, and we wanted the pen testers or the white hat community to have the same capability. We didn't want to have to spend the time to recreate a backdoor maybe from scratch every single time. That was obviously going to require like heavy time investment. So we wanted something that could quickly and easily automate the creation of a new AV evading payload. And then finally, typically what people want to do when they have a program that, or excuse me, a binary that they want it to be able to execute shellcode on the box. And it can be your shellcode that's caught, it can be the file template, it can be multiple different things, but that's our typical goal, is we want to execute shellcode on a machine. So we wanted to make sure that our payloads were going to be able to do that. So after our initial solution, Veil Evasion was obviously like our rough POC, and we came about with the Veil framework. What we wanted to do was basically bridge the gap between different pen testing tools and red teaming capabilities into one single framework that can be utilized on an assessment. All of our different tools, we we use each for their own specific role and help us when we're actually on an assessment to carry out whatever attacks we're looking to do. We started out with Veil Evasion, obviously, and we began to branch out with PowerShell for our situational awareness and for Veil Catapult to deliver the payloads that we create. And the big thing that's kind of funny here is nothing really here that's available is completely revolutionary. All of this stuff is already publicly available and pretty much already have been made available by a variety of different authors that are out there just posting their tools or techniques on the internet. So all we really did was just create a single framework that aggregated all these different techniques and just automated it. It made it easy for people to create new payloads. So when we were doing this, we had a lot of internal debates if we wanted to actually release something like Veil. This sort of debate is not new. It draws a lot of parallels to the exploit disclosure debate, obviously.
And actually, the code base remained private for about 4 to 6 months, which is kind of what I mentioned before. So the official release date was about a year ago, but we've been using it operationally for a while. Most pen testers have their own little tips and tricks for getting around AV, but most people tend to keep it close to the chest because the moment you kind of popularize a new technique, obviously the vendors are going to start to catch on. Our kind of solution to that is some of these techniques we think are still effective over a year later. They still get by a lot of solutions. And we've been constantly releasing new techniques and modules, which we'll go over a little bit later. So we just kind of want to push everything forward.
One thing that we noticed, malware developers are basically 5 years ahead of the white hat community. It's roughly what we've been told from a lot of blue teamers that are analyzing, the binaries that are being dropped. They're ahead of the game, and so we're trying to just catch up and match their capabilities as fast as we can. But they already have better TTPs than what we have available typically right now, or the white hat community, that is. But like I said, this is already a solved problems that the bad guys have. Like they don't have to deal with this. It's not an issue. So when we did this, after a lot of internal debate, we decided, and again, this is very similar to like the exploit disclosure debate, is we wanted to be able to have the same capabilities as the adversary out there. We wanted to be able to make sure that we can best emulate a threat or whatever adversary that we're acting as. And since they already have these capabilities, we believe that obviously the white hat community should as well. And so that basically led to us, okay, we felt fine releasing this tool.
Yeah, and again, this kind of a little similar. There's some parallels to the exploit disclosure debate, which has been going on for 10 to 15 years. So we really like this kind of quote from HD talking about the strongest case for information disclosure is when the benefit outweighs the risk, and which we think is true with a lot of these techniques. So the public reaction, these are actually quotes from the original Reddit thread when it was posted almost a year ago. You'll see, surely this will just give us 21 new signatures, we'll be back to square one. Isn't our field meant to be working towards increasing security rather than handing out fully functioning cyber weapons? So if you're playing the cyber drinking game, you should, drink. But then someone else had a good point that, the key here is that anything that helps expose how ineffective antivirus truly is at stopping even a minimally sophisticated attacker, and this is the emphasis, then we think it's a good thing. So despite, this kind of rough start where a lot of people are yelling at us and saying this was, ethically ambiguous and all that kind of stuff, we view it as AV has failed us. Symantec actually just posted that great article recently the other week saying AV is dead, which is kind of funny even hearing them say it. With the last POS malware kind of stuff that happened, no vendors actually detected anything. So our key here is at least we kind of have a caveat that signature-based detection is dead. So we really want to push stuff more towards heuristic behavioral type of detection, which they should have been doing for a while, but hopefully maybe we can give just a little bit of pressure to push them in the right direction. So this is, we have a couple of slides on some of the Twitter reaction. This is actually after the HarmJ0y presentation. So Chris Lipsky, he's one of the PowerSploit guys. The main thing that bothers me about the Veil framework is the new pen testers will never know what it's like to do this all manually, which we thought was funny. So again, most of this stuff, the Pi installer, everything we'll go over, it's been out there. We have a little bit of incremental research, but this stuff is already out there. We're not claiming to have invented it. And in reaction, Script Junkie is pretty well known. Back in my day, we had to obfuscate bits by hand uphill both ways, which we thought was kind of a funny quote.
Yeah. Okay, so Veil Evasion. So the thing that we are doing here, like I had mentioned before, is we looked to aggregate as many different techniques that are publicly available out there right now and add them into our framework. We wanted to make this super easy to select the technique that you want to use, add in whatever option that customizes it to fit your need, and then generate that payload.
And this has been things like shellcode exec, trend, pi injector, all these types of things. Like, again, the techniques are out there, so we just wanted kind of an easy framework-driven way to use them.
Yeah, like Python executables have been around for quite some time. Figuring out how to just wrap that up into a Windows binary, like nothing's groundbreaking here.
And I think the AV talk last year, when I glanced at it here at CarolinaCon, was actually about some of these native. He touched on a little bit of the native interpreter stagers and things like that, which we'll go over in detail again. So.
Yep. Some of the big things that we really wanted to focus on when we were developing the framework, or Evasion, excuse me, is that we wanted it to be easily automatable, the usability to be, or that the tool is really easy to use, and that turn it into a framework where there's users can either develop their own private modules that they can keep to themselves, but easily just drop in, and the framework will pick it up. We wanted something that was extensible and very easy to use, because in my opinion, probably a fast death of a project is something that you feel is going to break all the time and you can't count on it, because when you're in the field and when you're on a test, you need something that you can rely on to get the job done, and we wanted to make sure that we had that. Finally, we also have added a couple auxiliary modules into it as well, so it's not just pure AV evasion, but we have the capability to just simply wrap up like your Python script into a Windows executable, or convert an existing executable into a war payload in case you're looking at like a Tomcat box or something like that. So some of the different features that Veil Evasion has is that you can use Metasploit generated or custom generated or custom written shellcode. The Metasploit framework's payload tree is dynamically loaded, excuse me, and then so you can easily use basically any Windows payload that's in the Metasploit tree currently. We're also currently in the process of trying to port MSF Venom into Python. One of the issues that we actually ran into is when the Metasploit guys changed the output of MSF Venom, it messed with the output that we were expecting, and so our payloads are crashing for a little bit. So what we figured that we wanted to try to do is make something that we know that we control that has the same capabilities as MSF Venom, but then it's therefore not going to hit any like unexpected issues, and because we know that we write the tool and that it's reliable and that we get our expected output. The other thing that's interesting is third-party tools can be easily added right into the Veil framework. So this is like Hyperion from Null Security, PE Scrambler, and Josh Pitt's Backdoor Factory. We've actually added all these in, so they're ready to be used within the framework. And finally, we also wanted to have command line switches so that your different payloads, if you don't want to use a menu-driven system, you can easily just provide any necessary command line switches, and then that'll let you rapidly generate a payload and or script it up if you want.
And part of the motivation with that too is along with the fact that we, say we want to generate 1,000 EXEs for static analysis testing or something like that. We also wanted to make it as easy as possible to integrate this tool into your own project. So the easiest, it's kind of a hack, the easiest way to do that is by being able to script it up. So every single option has a flag. For example, when we actually have a Cortana script for Armitage or Cobalt Strike, they'll integrate Veil Evasion natively, and that wraps all of the scripting arguments and everything to just pop it right out.
So one of the things that we really wanted to try to do is have a single attack platform. With that in mind, we wanted to figure out, okay, how can we make sure that we can generate as many executables as we can all within Kali? Because Kali is our main supported OS. It'll probably work on Debian-based distros, but we officially support Kali. And so what we found is that with Python, we can use PyInstaller when Python and PyInstaller are installed in Wine within Kali, we can generate a valid Windows binary directly within Kali without needing to drop into, have a second Windows VM. Now, Py.exe, that actually does require a Windows either VM or separate computer, because that can't create valid Windows binaries under Wine.
And one of the advantages, which we'll go into the Pi installer stuff here more in a little bit. One of the advantages we had with Pi installer, a reason for using it, and the reason it still works a lot of times, is a lot of valid projects or programs will use Pi installer to distribute their actual binary. So I think Dropbox might use it. Volatility for their Windows distro actually uses it and things like that. So the fact that it kind of almost acts as a de facto little good like packer or obfuscator essentially lets you kind of ride on top of that existing functionality and all the signatures and stuff while being able to deploy malicious logic.
Yeah, because basically we were hoping that that AV vendors wouldn't just straight flag Pi installer because of all the legitimate use that it has, that it would cause issues with their users, obviously, because they're going to be using other stuff. We have Mono, the Mono library built into Kali or it's installed when you run Veil, and so that allows for native compilation for .NET payloads, and then MinGW also, all within Kali.
And again, we never want to introduce a language or a module or anything in the Veil framework or Veil Evasion that won't let you generate a native Windows executable straight on Kali. So even if there's new techniques and things like that we want to integrate, sometimes we actually have to put them on hold because we want to make sure that everything is natively supported.
Yep. So for a quick talk on our philosophy behind module development is right now we have a ton of different Python-based payloads. Now we obviously do have C, C#, a couple other ones, PowerShell, different payloads that are in there. But Python has completely written out where we have like a flat Python script, or your Python code is AES encrypted, or there's different obfuscation techniques. What we tried to do is for each payload, we created like the base foundation where it's just a flat, normal script. So any person can actually go, any user, look and figure out, okay, this is how this payload has been created, so they can see like there's no obfuscation within it. And then you can kind of use our other payloads like Python and say, okay, now I see their base, and here's like how they're doing some sort of encryption. Okay, maybe I can now build off of this and create my own payloads and use some sort of other different encryption or obfuscation technique. So we wanted to give the user the ability to see what we were doing so that they could easily modify that and come up with their own payloads.
And there's actually a blog post right there. And actually, we forgot to mention, these slides we actually posted just before the presentation online. So if you check out the CarolinaCon hashtag, it's posted up from our official Veil Framework Twitter account. But this blog post actually gives you really good detail about the reusable libraries and the payload module setup and all that kind of stuff in case you actually want to implement your own private methods, which we know a few people have. Because, we hope that someone wants to give us a pull request, but we're not counting on it. So if you want to do your own stuff in a really nice way and have it all packaged up and take care of all the back-end heavy lifting, please use this. Please feel free to. If you want to be really nice, send us a pull request if it's something cool.
So just a super fast primer on, this is how we're actually getting our shellcode to be executed in memory on a box. We don't want to go too in-depth into this, so if you guys have questions, you can just hit us up like on a forums or something like that. But there's three primary techniques that we're using. One is void pointer casting, so this is like your traditional void function pointer where our shellcode is stored in it, and then we basically try to execute that. The one main issue with void pointer casting is basically after XP, so like Vista and above, I believe, they're all going to have depth enabled. And so, okay, so that's going to be an issue where we can't completely rely on that if the memory region is not executable. The two main methods that we try to promote is virtual alloc and heap alloc. And so these are basically just two different methods to allocate memory within a process, tell it, hey, any code that I shove in here can be executed, and then actually running your shellcode.
Yeah, there's a really common little pattern that people have been using for a while. You do virtual alloc, allocate the executable page, do RTL move memory to move the data in, create a thread with it, and then you wait for it to execute. So again, we did not invent this. This has been around. So Chris mentioned depth. So data execution prevention. Even though it's a exploit mitigation, in 5 seconds, it's an exploit mitigation to prevent the execution of usually exploit code, in particular data pages. It was originally built to prevent stuff, if you have an IE overflow or whatever, something like that, then that first initial stage shellcode, it makes it a little more difficult to actually get the initial execution. So, and Chris mentioned the void pointer thing. So the issue we ran into was, if the area of memory, when you're using void pointer casting, if the area of memory is not explicitly marked as executable, then that payload is going to fail with an access violation. And what we are running into was, there's a weird little bug where Python scripts, if you just ran them straight on a Windows box, just, you know, if Python was actually installed and you would just run it to inject the shellcode like this, it would work. But if you ran it with a PyInstaller exe, it would fail with an access violation. So after tracking it down, we found out that PyInstaller exes actually opt in to depth protection, which ruins the void pointer casting stuff. And PyInstaller includes this little loader. It's basically a little loader and then a big compressed file at the end and extracts it and all that. So the little loader is pre-compiled and included with PyInstaller, and that's what actually opts into depth. Luckily, PyInstaller is open source, so we can recompile it, turn off the depth protections and all that. So we have a blog post about that, our Veil framework, or Veil Evasion depth PyInstaller. We didn't include a recompiled version of the loader with the framework initially because we just had a statically custom recompiled little thing. Then it would give vendors a perfect chance to be like, hey, this is precisely a Veil Evasion payload. So we just kind of included these instructions for people in case they wanted to recompile it themselves. But then I actually gave a presentation last weekend on something called PwnStaller. So it's a generator for obfuscated PyInstaller loaders. Dynamically, every time it's run, it can be run as standalone or now integrated into the master branch of Veil Evasion. So whenever you run this, it is a completely obfuscated and randomly generated little loader that is then copied into the PyInstaller location, and everything else is wrapped up like normal. So there's a blog post on there on PwnStaller 1.0 if you just search for it. So with this and the fact that if you choose the PwnStaller option and you're generating stuff, every single time the loader will be dynamically recompiled on Kali. So we felt like this was a reasonable alternative. We still don't have it as default, but it's at least not a static recompiled exe every time. So this kind of was the result of tracking down that depth bug and also trying to obfuscate as much stuff as we possibly could.
So V-Day. Basically, since September 15th, we've tried to release at least one new payload or multiple payloads each month, which either is in a new language or a different technique or something that we're doing just to continue to support the tool. Currently, we have roughly like 32, I believe, yeah, because yesterday was our V-Day, or 2 days ago. So we now have 32 different payloads that are currently in the framework, and we have at least 20 built that are still under testing, that we have rough proof of concepts working. So we plan to definitely be supporting and continue to release new techniques for quite some time.
And some of these have been combined, so like any Python payload has 3 different shellcode injection options. It has expiration options in case you want the executable to only be valid for, say a week during testing. So some of these, even though there's only 32, there's a lot of techniques kind of under the hood.
Yep. So there's 2 main types of payloads that Veil Evasion really has in it. There's your normal shellcode injection type of payload, and then we also have an interpreter loader. So the shellcode injection is kind of what we were just talking about, is we have these different techniques to take shellcode, place them into memory, run it. But what we also have now are native stagers that are built in whatever language that we wanted to do, write it for. So that's the big thing, is that stage 1's stagers from interpreter don't have to be implemented purely in shellcode. They can be written in different higher level languages, and so that's what we've done.
This is the original POC that we had found from Raphael Mudge. It's a little C interpreter loader. And we'll go over how it works here in a second.
Yep. So as of now, we have a variety of different just native stagers. So we have Python for like your reverse TCP or HTTP or HTTPS.
And the contain thing, what that actually is it takes the entire interpreter DLL and obfuscates it, packs it up into a Python script, and then injects that in memory, so it immediately starts its beaconing behavior without actually having to stage stuff over the wire.
And we also have C# and C different payloads.
And we just released, the V-Day this month was the C# interpreter, HTTP, and HTTPS stuff. So really quick, I think this was actually covered a little bit in the presentation last year, but how stagers work. So when the stager starts, it first opens up a reverse TCP connection to the handler, opens up a socket, and the handler sends back 4 bytes, basically telling you, this is how much data that I have. It's usually around, what, 750K or whatever it is. Right after it spits that back, it transfers the entire DLL over the wire. Up until recently, that DLL had been in the clear for reverse TCP, and now they have like full stage encoding stuff and all that. Then the socket number for this TCP connection is pushed into the EDI register, which I'll explain in a second. And execution is past the DLL, just like regular shellcode. Whether you want to do the void pointer thing or virtual alloc or heap or whatever it is. And the reason that socket number is pushed into EDI is because when the interpreter DLL starts, it pulls the socket number out of that register, so then it can use that same existing connection for its C2. So it doesn't have to stage over one connection and then like open up another to actually get command. So they write on top of the existing network socket. And the reverse HTTPS stagers and HTTP stagers are actually a lot easier. The handler just spits the DLL back and you just immediately start executing it as it's reflectively injectable. So because HTTP, they binary patch in all the handler URL and port and all that kind of stuff on the server side. So you don't have to do the little weird registry, little EDI trick thing.
Cool. Oh, go ahead. Can you pull it up?
Yep. We actually have a video for this guy, and we'll have live demos for the other two. Hopefully you can see it. We tried to make it about as big as
Yeah. So what we're basically showing right here is this is your typical MSF Venom generated payload. So it's actually being generated right now, and the point to show is that we're about to drop it on this Windows 8 VM, and it's going to get caught. And this is the problem that a lot of people face because they want to generate, obviously, this payload, and we're about to get flagged. So we're flagged, and it can't work.
And we're using Security Essentials here, and it's been updated and all that.
It's up. Yeah, this is up to date as of yesterday. So we're about to go over using Veil Evasion. And so these are the different options that we have right here that are available for use. Just a quick talk on some of them. So update is obviously you can just quickly update the Veil Evasion right there. Clean will clean out any of your existing payloads that you currently have within any of your folders, including the source. And check VT is something that we use based off of Rob Fuller's check VT script. And what it does is, so first of all, we are not advocates of VirusTotal anyway. Don't submit your operational payloads to there, obviously. If for whatever reason, against all your best wishes, you still want to check your payload, what you can do is check VT. We actually store the hash, I believe it's the SHA-1 hash of your payload, and then through VirusTotal's API, we don't send your payload, but we send that SHA-1 hash of your payload to VirusTotal. It'll then query VirusTotal and try to determine if this is actually a known flagged executable or not. So for basic usage, you're just going to type list, and you're going to see all the different payloads that are available. So these are our auxiliary ones where you can wrap your payload into a WAR file or Python, or convert a Python script into a Windows executable. So if we're going to use this flat injection, there's 2 different ways you can call it. You can tab complete the name, or basically just give the number and tell it to go. So here's different different options that you can set for your payload, such as if you want to use Pytherian, which is a Python obfuscator, or change how your shellcode is injected. After that, it's, okay, where do you want to get your shellcode? Do you want to either supply it yourself, or do you want to invoke MSF Venom? So here, it's just using MSF Venom's reverse TCP, and we're providing the IP and the port for it to connect back to. After it's received the shellcode, it's just asking for your name. And so here is the option where you can choose, okay, do I want to use PyInstaller, or PwnInstaller, or PyExe? And in this case, we use PwnInstaller, where it generated a new PyInstaller executable, which is then used to wrap up the Python script into a Windows binary. And it finished and it wrote it out. So this is what your output looks like. You have your compiled code, which is where your Windows binary is. And so
we also preserve all the source, and we automatically generate a handler script in case you want to use that.
Yeah, we have the source code in case, just so you can see what's actually in the Windows binary, so you know that we're not backdooring your backdoor. Under handlers, we have a quick handler script that you can invoke for Metasploit, which will auto set up a handler for you and just get it ready.
With whatever options you specified, it'll pull out the LHOS, L port, and all that.
Yep. And so you can see here right now, we have the binary dropped on disk. It hasn't been caught. So we're pretty confident with that. And once this gets loaded up, we'll execute it and make sure that we actually get our session back. So there's the MSF, Metasploit framework, finished loaded up. We're going to run it. And we have our session.
Yay. Cool. And again, this, we've been using, people have been using this technique with the file installer stuff for a while. This was recorded yesterday. It still works. So
Yep.
I wouldn't worry too much about it.
Up to date as of yesterday as well.
Yeah. Cool. So the next step we kind of took when we were logically thinking about this stuff was, now that we can generate these things, how are we going to actually deliver them to a box? There's existing stuff out there, SMB exec, Metasploits, PS exec, and all that. But we felt there was a couple gap areas, and we just kind of wanted to build something that really worked exactly how we wanted it to. So this product was Veil Catapult, and here's our nice little graphic. That's the little Metasploit logo, and that's Security Essentials, because, yeah, they're funny. Again, our focus shifted to delivery. So Veil Catapult actually has really nice, seamless integration with Veil Evasion. They're both written in Python, just the whole kind of framework approach. So it can invoke Veil Evasion very, very easily. Drop into the main menu. We'll show that here in a second in the demo. Everything is like all the same tab, completable, all that kind of stuff. We also have cleanup scripts for everything. So if you upload and execute something, then it'll kill the process and delete it. And if it just executes, it'll kill everything off. Because we always want to leave a client's box in a pristine state. And this is something, I don't think this is really out there in some of the existing tools. So this is the original kind of main motivation for building this. We also, again, have command line flags for every option, kind of keeping with that theme for the Veil framework. We want you to be able to integrate it externally with whatever you need. And we have a nice little write-up for Veil framework / Catapult. I think this is actually released around the ShmooCon timeframe, so we've been using it operationally for a little while, and we think it works pretty well. So EXE delivery. Users can invoke Veil Evasion to generate a payload, or you can specify your own EXE. And there's two main ways that these are delivered and executed on a box. The kind of underlying primitives we have are, we use Impacket for file transfer, and we use the passing the hash toolkit, which was released a couple years ago at Black Hat, which basically are patched versions of WIMS and PS exec that will run natively in Kali. So you use apt-get install passing the hash, or I forget whatever the exact package name is. So the first method is kind of the classic, where you upload the exe to the box, and then you trigger it either with PS exec or WIMS. And the second little trick we introduced was using Impacket, we'll actually throw up a temporary SMB server on the attacker box, and then we trigger it with a UNC path that goes straight back to your machine. So this will actually load up the exe straight into memory without touching disk on the target box. And the funny thing about this is it gets some otherwise disk detectable executables right by AV. So if you take, like, say, the stock interpreter stager, oh, sorry, let me back up a second. So, like, you can do this, and it'll get stuff straight into memory. So if you generate the stock interpreter stager, and you try to drop that in disk, it'll actually, like, flag and everything. But you can do some of these things and actually load them straight into memory, and it'll get by detection. But a weird little thing is occasionally MSE and some other things will have in-memory, they've started to have in-memory signatures for certain things, like some of the stock loaders, but not for everything else. So it's really kind of, I don't know, it's a little kind of inconsistent behavior. But we generally try to use this on assessment because no artifacts are going to be touching disk. We also have some just kind of like initial standalone payloads that payloads or TTPs that we always tend to use. So you can use PowerShell to trigger shellcode injection. I think I originally read about it on the Exploit Monday blog, one of the PowerSploit dudes. Then we also have a kind of bare bones Python injection, which I'll talk about in the next slide for a second. But it basically uploads a minimal Python environment in a zip file using Impacket, and also uploads a 7-zip binary, triggers it to unzip, and uses a command line flag to actually execute a little Python program all in memory. So like nothing, no malicious logic is actually touching disk. We also have the sethc backdoor. It's been around for a while. I think I heard about it in some training a few years ago. Rob Fuller talked about this at DerbyCon the other year, but it's this neat little trick to where either you copy over CMD or you copy over the CMD.exe to the sethc binary, or you can do a little registry key. But when you try to RDP into a box, just on the login screen, you can press shift 5 times and you get a command prompt running in a system. So we have that, and we have cleanup scripts for all this stuff as well. So bare bones Python, this is like our little slightly kind of novel thing. But like I mentioned, it uploads a minimal Python zip installation that was kind of hand stripped to just the minimal amount of program files that are needed to run Python C types to inject shellcode. And then after it's unzipped, it uses this -c, and you can pass a like little minimal Python program on the command line, just like you can with PowerShell. So the only files that touch disk are the trusted Python libraries and the Python interpreter. And this gets right by some reputation filters, right by some AVs, not everything, but it's kind of along the same idea as like a PowerShell injection. We just applied it to Python as well. And there's a blog post up there, bare bones Python, if you want to hit up our blog. We normally write in pretty good detail about everything. So let's see if this works. All right, so the first thing I'm going to do is edit the settings. We have this global settings file for the Veil framework. We have stuff, like where you want your source path, compile path, everything like that. So the Veil catapult section, we have the option now to automatically spawn a handler. So we'll launch this. And the formatting is kind of messed up because we tried to make it as large as possible for people to see. So the standalone payloads I mentioned, the PowerShell injector, the sethc backdoor, and all that kind of stuff. You can execute this if you want. So what I'm going to do is I'm going to go into the exe delivery. And you can either specify custom path, it should be tab completable. If you press enter, you'll drop right into Veil Evasion's normal interface. So I'm going to use the C interpreter verse TCP. This is a native C obfuscated interpreter payload. It actually has not just kind of the static obfuscation, but it has a bunch of like obfuscated methods and stuff and a bunch of like dummy logic and things like that. So the call tree itself is actually obfuscated pretty well. So I'm going to do set lhost, leave everything else the same, press generate, it'll compile it all up. This is just like the Veil Evasion stuff for the output. Now it's going to automatically spawn this plate handler, new window. Give it a second. Okay, handler's going. Now I have like 4 or so Windows boxes running in the background. I'm going to use just like a local password with the awesome password of, or local user with the awesome password 123. Here we have the option if you want to do WIMS or WinExe. WIMS will not create a service on the box, so it can be a little more stealthy. But WinExe, which is like PS exec, will run a system. So it just kind of, depends on what situation you're operating in. So here you can either host it, like I mentioned, host and execute, or you can upload and execute. So I'm actually going to host it. And you have to enter the local IP so it can reach back, and we can tab complete that. And then enter to launch. So what this is doing is it sets up that temporary SMB server, and then it triggers, like // come back to my IP and actually load it straight into memory. So we'll see, then it kills it off, and there we go, there's our session. Cool. But then we also have this auto-generated cleanup script, same under that Veil output catapult. It'll be like a little RC script that's time-stamped. If you run this, it should go in, kill off the process, and there we go, our session died. Cool. So the next thing that we kind of moved into, and this is since ShmooCon, so this is a little bit of the new material, is it started moving into PowerShell for post-exploitation. And if people say, like, why exactly, I don't know, if you don't know why people tend to use PowerShell, you have full access to .NET, you can execute stuff without touching disk, you can actually write fully functioning malware in PowerShell. It's included in almost, I think, every single Windows 7 box, 2008 and everything else. Now that XP is end of life, you're basically given a whitelisted, trusted binary that you can do whatever you want with on every single box you're touching. People have started to write really good, powerful post-exploitation PowerShell toolkits. So like there's Nshang, there's PowerSploit, there's PoshSecMod from Carlos Perez. There's a lot of projects that have started to come up. So our specific thing that we felt like there was a gap area is situational awareness. So your initial goal in situational awareness, whether you're doing a pen test or a lot more frequently, a little bit more of a long-term red team, is you want to gain a deeper understanding of an exploited host or network so you can further deepen your infiltration. So normally what you would do, hopefully everybody knows this, find the users, NetView to get the shares on a particular host, find out who the domain admins are, and you want to try to start hunting down, like, where are these people, so you can try to get additional targets and figure out what you want to do. There's also like NetSesh, like an old tool for getting sessions off of boxes. Or there are some custom tools where people would start to take advantage of some of these particular Windows API calls. So the result that we built was Veil PowerView. It's a pure PowerShell situational awareness tool. Again, there's no little blog post about it. And it initially started because we were on assessment where a client had blocked all net commands on host, which we had never really seen before. So that definitely messed up our initial lateral pivoting. And they were like, haha, you can't do anything. It was really annoying, so we went back and just a couple of days later wrote pure PowerShell replacements for all .NET commands. So if they have PowerShell running, even if they block net, then we can still do whatever we want. Then was actually kind of inspired by Rob Fuller's tool called netview.exe, which was released at Derby in 2012, I think. And what this does is it utilizes some particular Windows API calls to do things like get shares, get the logged in users, and get sessions on all boxes in the network very, very quickly. But it's a little inflexible. It's a great tool. It's a little bit inflexible, and it's also written in C, so you have to drop a binary disk. We wanted something straight in PowerShell so we can, do straight in memory execution, have a few more flags, and it's a little easier to modify PowerShell stuff than rewriting the entire C base. Then from then, it started to kind of explore and expand some of the functionality. So this getNet, these are all full feature replacements for almost all the net commands. It utilizes some Windows API calls for weird stuff, but also PowerShell AD hooks. So anything that you can do on the command line, it just uses this Windows functionality underneath, so you can hijack and basically do the same stuff with PowerShell. Things like, get net users, get net group, get net servers, and all that kind of stuff. There's a README that has a complete list of everything that's replaced. There's also ways that you can add users, add them to groups and all those types of things. And we're actually going to have a full usage guide on operationally actually using PowerView. It's going to be posted on the main site in the next couple of weeks. But the really fun stuff are kind of the meta functions. So invoke NetView is a full PowerShell replacement for netview.exe. So you can give it like a host. You can also give it like a jitter or a delay, or if you only want to touch a box like every 60 seconds with a 20% randomization interval. So if you want to do this a little more sneakily over a longer period of time. You can, all the shares that come back, you can actually check if you have access, all that kind of fun stuff, and output the solo file if you need to, which I'll show. That'll be the last demo. Share Finder actually will crawl every host in the network, find every share that's available, and then check, do I have read access to every share? So there's a common thing we tend to do on engagements, and it'll just dump out this entire list that you can start kind of triaging. Find local admin access is a port of the local admin search enum Metasploit module, and it uses this little API call to open up the service handler in a remote machine. So basically, you run this, and if it returns true for a machine, then you can ps exec with the current user to that box and take it over. Invoke find vuln systems that actually queries AD and filters for machines that are likely vulnerable to 08067. So you can actually specify the OS and the service pack and everything. And you run this, and it can dump out a list of saying, try to go, pop these boxes without having to actually scan and run Nessus and do everything else. And this is the really cool one, so user hunting. And the goal here, like I mentioned before, is find out which domain machines specific high-value users are logged into. So invoke user hunter will use two particular API calls, which will get the sessions and the logged in users for every machine, even if you aren't admin on that machine. So you can be a normal user and run these commands, these API calls against target boxes, and it'll tell you, here's all the people logged in, which is kind of weird that they allowed you to do that without permissions. I don't know why, in their infinite wisdom. But this invoke user hunter wraps everything. So you can specify a host list, a username, all these, everything that you can basically change can be changed by flag. But by default, if you run it, it'll query AD, it'll get all the machines in Active Directory, it'll go to every machine and run these like net sessions and net logged in, and it will then query Active Directory for whoever is a member of, by default, domain admins. You can specify another group. Then it'll check to like see where they match up. So through every machine in the network, you run this and it'll tell you, here's where all the domain admins are logged in, which is a really common task that we had to do on almost every assessment. So we just kind of, now we can just like run this, come back 20 minutes later and it'll tell us exactly where we want to pop. Stealth User Hunter actually uses a red team trick where you query AD, get all the users, extract all the home directories out of there, which is where like your file servers are going to be mounted. Then you run net sessions on all those file servers. So normally it's like, depending on the size of the org, anywhere between like 2 and 20 boxes. And then you match that up against whatever the target user list is. So the end result is you might not get all the coverage on all the machines like you would with User Hunter, but there's very little traffic that comes out of this. It's like one AD query, and then you touch maybe, say, 5 boxes with a little bit of SMB traffic, and you can find out where a lot of users are logged in. Cool. We'll see if, here we go. So I'll go ahead and start up PowerShell. You want to do no profile and exec bypass because it has like a little security mechanism that says you can't run these additional files. But if you just do exec bypass, then you can. Import module PowerView. And this will load up all these like little commandlets. So this is the README. Here's all the 25 or something functions that it has. So if you want to do like git net computers, this will query AD and give you like all the names back and everything. If you need help on anything, you can do git net help. Everything's documented. You have like examples, all the commands, like usage and all that kind of stuff. So we'll do a couple of cool ones. User description search. This will query AD, get all the user descriptions and search it for a particular term, like password. This actually happens in organizations, even though it's stupid. Like people will put the password for this account is blank in the description field, like if it's backed up as a backup account or something like that. So this, you can go ahead and hit that if you want to. Then we'll run invoke netview and show you. This is a very similar output to what Rob Fuller's tool was with default. It'll run, query the domain for all the hosts, get the domain controller, and for each server, you see here you have here are the sessions, from where, here are all the shares, here are the other boxes. So it'll just dump all this stuff out. You want, here are all the particular flags, like if you want to check access for the shares, if you want to ping the machine before you actually enumerate it, shuffle up everything, do a delay of 60 seconds or something like that. If you want to output stuff to a file, you can do coding. You can output stuff pretty easily. And this is all greppable with the little like plus and minus and everything like that. So invoke share finder is the thing I mentioned where it'll actually dump all the shares on the domain, and you can check all the access for it. So it'll just dump this all out very quickly. You have things like, users, secret share with the comments and all that kind of stuff. I'm going a little faster because I know we're almost out of time. So invoke user hunter. This is a really cool one that I mentioned. The flags are you can specify a particular group name to query, a username to target. You can check to see if you have local admin access to any of the found boxes, ping them, shuffle, delay, and all that kind of stuff. So what this will do is query the domain for domain admins, enumerate all the servers, and then told you, oh, look, here's this user who's a domain admin logged into this box.
Awesome.
Where is it?
Cool. So everything that we went over here today is all up on GitHub. You guys can feel free to go grab it, use it. Send us a pull request if you have either your own payload or any sort of modification that can help tweak it. Each project has their own repo under there, but we also have just the overall Veil repo, which contains everything. It's like our meta
And
repository.
it's like a master project. You pull down and pulls down the current stable branch of everything. We also have a development branch for Evasion. So whenever we push kind of experimental stuff to it, we put it there first, and then once a month on the V-Day is when we merge the dev branch into the master branch. So we're trying really hard to make sure stuff's stable and
Yep.
branches are deleted.
Yeah. We have our main website, veilframework.com, where that's where we have any sort of update or like where we document the additions that we're adding to Veil, or just basic tutorials and videos and guides on how to use the different features.
And we do at least one post every month, minimum on the V-Day thing on the 15th, and we'll tell you what's been updated.
Yep, and it's also available in Kali, so you can easily just get it straight from their repos. Although we typically recommend, to make sure that you guys are getting the most up-to-date version, just clone it from GitHub. So does anyone have any questions?
I know we're kind of out of time, so if we run out and you guys can just meet up with us in the hallway or something if you want to talk to us. We also have forums. We have a channel on Freenode. Email us. Like, we love talking about this stuff. So.
Yep. Question? Thank you.